So predominantly, there are so many aspects. You can just put them into three categories of threats. One is harvest node decrypt later threat. This is what you hear quite often every discussions. It's all about if there is a data which has a sensitivity and it has a shelf life of more than 5 years and above, that means you are already at threat. So simple reason is I can store that data and decrypt it later. So those use cases are already at threat. So it basically the confidentiality is broken. So that's the use cases. The other one, which is another next one, which is being heavily discussed, is about trust now forged later. It's about related to earlier one is more data protection. The second one is more about trust. Your signatures, wherever you are using signatures for all your certificates, anything of that kind, is being questioned. So what I can do, I can retroactively, I can go ahead and break this, and you will be thinking that this property is yours. I'll break and sign it again with my signatures, and I can claim your property is mine. So those kind of trust itself will be broken unless you do take care of this. The third one is a little more systemic in nature. So this is where the crypto agility, the ability to do the migration comes into the picture. For example, you have a system, maybe an ATM system or any other platforms, large scale platforms which you are developing. They need to survive beyond 10 years, 20 years, like that. In such use case, if you deploy those systems with current classical vulnerable cryptography, if you don't have a way to upgrade them tomorrow with either crypto agility or any other form, then those systems will stay vulnerable in your environment forever till you replace them. The cost of replacement is huge because those systems were not designed to do the upgradation or bringing crypto agility. So that's the reason this is a deploy now. You deploy it today, and it will be exploited later for a long period of time. So these three important threats you need to keep it in mind, and start looking at your systems from this angle. So CRQC window is shrinking. 2029 is what at least Google is talking about based on the latest note. But the migration for large organizations can take 5 to 10 years. So that means the time available is shrinking. It's already shrunk rather than, I would say, shrinking. Now, BFSI as a sector is one of the sector which has highest exposure and also the most active sector when it comes to globally on quantum safe migration related activities. Since there is a lot of long-lived data, the sensitive data which is there, which you need to deal with, the harvest node decrypt later threat is quite active. And you have a lot of PKI systems, signatures, basically certificates, all this will have. And an important point is very attached to the complexity for BFSI, especially if you have a lot of legacy systems. So legacy systems, if you have the migration will not be easy. If you are following the modern architecture, it may be as simple configuration may be enough to introduce PQC algorithms or hybrid PQC algorithms. But if you have legacy systems which is difficult, is hard-coded or monolithic in architecture and all that, it significantly adds. And quite a lot of banks still, I'm sure, will have a lot of such legacy systems. And on top of it, there is a lot of third-party dependency. If you look at your organization, I'm sure there will be merely 50% or maybe around that, or even some cases even more, will be dependent on vendors. So all those systems, whole infrastructure, applications, everything, you are vendor dependent. So as an organization, you are responsible to be compliant, to be quantum safe and all that. Vendor may not have different kind of plans. So there may be some of those products might have reached end of life. Some of the products, they may not want to upgrade because of various reasons, because hardware may not support. So you need to start talking to them. So those dependencies are huge and adds to the complexity of the migration. And regulatory is quite active, and you can see, Teja just mentioned that RBI has already started working on, created a new committee to come up with some kind of regulatory. SEBI has already introduced some basic expectations in the CSRF in 2024 itself, and the systemic risk amplifies. There is one very good study report, which is a reasonably old report, Hudson Institute, which has done kind of simulated this. I take it, if just a single use case, the wire transfer use case, if it gets affected in US only, the impact is $2 to $3 trillion. So that's the size of systemic impact it can have, and more the critical systems, critical industries will have even national security related challenges. So you will be thinking, so what should I do? How do I go about addressing? That's a basic question. Like, a lot of people are aware of this threat, they know this threat. The next question is about how do you move from being awareness to getting into some action, and what kind of activities you can look at it. So that's where the plan, thinking through this as a program, not just a simple project or simple one-time activity. You need to think through like a program which you will run over a period of many years, and what are the phases involved, and how do you approach this. The first phase is the foundation phase. It's more about getting your organization ready for action. So here it's all about education, getting the stakeholder engagement, doing some kind of a high-level understanding of risk of this. It can be very simple, but it will help you to understand where you stand as an organization. Do some kind of a high-level risk assessment at a systemic level. You don't have to go at asset level. It will help you to prioritize those systems than going on big bang, cryptographic bill of materials. Focus on those systems which matter most to you, and start setting up some kind of a COE or a program office, something which will focus on this, because you have to start talking. This small unit has to start talking to every division, every system, every application owner, everyone. So they will help you to coordinate and come up with a better plan for you. So this is where the education comes into the picture. Of course, the more you are informed, you will be in a better position to make the right decisions, and otherwise procrastination becomes heavy. Simple reason, fear of unknown. You don't know whether you're doing right thing or not. So getting awareness, getting educated on this topic is quite useful. This is exactly, I think, will help. The next phase is the preparation phase. This is the phase heavily discussed, and everywhere you hear, every cybersecurity guidelines, every document talks about this. This is basically start doing cryptographic bill of material or do a cryptography discovery. Yes, this is essential. So this is the one activity. I think the next slides are mostly focused on this topic. The next one is quantum risk assessment and management. Basically, you have to do comprehensive risk assessment and understand what is the impact of quantum threat for every asset in your organization. So you may have to look at timeline aspects of it, the feasibility, the migration feasibility, data security, data risk aspects of it, or quantum threat angle, whole cryptography itself, and vendor dependency aspects, policy and compliance. So all these factors you need to consider when you are doing the risk assessment, so that you are comprehensive in nature. You can simply do, okay, this is a cryptography artifact, this is why this has a vulnerable algorithm. It will get affected. Yes, you can do as simple as that. But if as an organization, it's not just about technical cryptography artifact only. It matters how does it affect to your systems, your organization, your assets. Then based on that, you will be able to do a better prioritization and do your planning. And the most important topic is about crypto agility. Don't think this may be one-time activity. So you may be possible, difficult to predict, that you may have to change this again in coming years. So if you have not architected your design systems such a way that you can change this cryptography with a simple configuration, that's the best case, that too dynamically, then at least look at the level in which you can achieve this crypto agility for each system, for each asset. So that will become very important topic. I'm not sure how much will be covered, but start assessing every system and asset. And vendor and supply chain becomes very important. Start doing an assessment. This is all in the preparation. And as everyone we can imagine that PQC algorithms have very different properties. Like when it comes to computational performance, some of the algorithms are better than RSA, but better than RSA, but not as good as ECC. But when it comes to the key size and the impact on the network and memory and all that, everything is not good. So based on the use case, you may have to pick and choose what is the right PQC you will select, and the hybrid nature of it. So start doing pilots of that. Start experimenting with those libraries. There are open source libraries available. You can start experimenting with them and understand how does it affect your system's application behavior. Try to create a real world use case, the scenario, and see how does it affect. It may affect, may not affect, but depends on the application and use case, how extensively it uses the PQC. If you are doing a lot of handshakes, it will get affect. If you just do once in a while some handshake and do continuously encrypted communication, it may not affect. So you have to look at it each application case to case and understand the impact. And many times changing the PQC is easy, but operationalization and deployment can become quite complex. Sometimes may not be feasible also. So technically it may be quite easy. I can create a new application ready, but it may not be possible to deploy and operationalize it. Look at those aspects as it. So then you should have a comprehensive plan of this migration, how you will go about to do this migration. That is all about preparation. That's exactly what you will see from a CSCRF requirements perspective. That's what I think preparation is what is expected. If you need to be compliant to CSCRF requirements, I think these are the things you need to look at it. Then the next phase is about a migration phase. In the migration phase, you'll start looking at how do you introduce PQC. like you may have to look at various patterns of usage. Like you may not be just go ahead and replace some use case with maybe in a particular TLS. Bare minimum you have to do 1.3, and you may be able to simply introduce, since the Chrome already supports X2559 plus MLChem 768 already. So your application side, you may be able to change it. But what if there are dependent systems? Other interoperability, backward compatibility challenges will be there. So in those scenarios, you cannot just migrate or upgrade it. So you have to take care of how transition you will make it. You may have to put 1+1 standby, one over the other. The various combinations you have to think through. The patterns of migration you need to consider, whether you use hybrid or PQC directly, and how do you deal with the certificates. This will become a challenge, especially WebPK, because of the key size. The signature sizes are huge. There is also a discussion of new WebPK system based on Merkle trees. So if that adds, again, there will be a significant disruption in the PK system. How do you approach the WebPK? So start looking at it. At least if you are aware of this problem, then you will be able to deal with them better. And also you will depend, especially the high security systems will depend on a lot of HSMs. HSMs take time to procure. It takes like the queue today to get the CMVP certification is almost 1 year, so it will take quite some time. So these are the kind of things you'll start looking at in the migration activity. It's not just about introducing PQC algorithms, right? It's that may be easiest among other activities when you compare to them. Then post-migration is all about ensuring that you don't reintroduce this thing ongoing way, in an ongoing manner. You will do the risk assessment, and the crypto agility is maintained, and you introduce this assessment and quantum safe practices in your DevOps, so that you don't introduce the vulnerable stories, any vulnerabilities later, and ensure every procurement process, everything is ensured that it is quantum safe. Whatever you buy is having PQC algorithms or support for PQC algorithms, those kind of things, and ongoing regulatory reporting will come into the picture. So these are the 4 phases of migration, which you will. So each phase has a different set of activities, and don't again think like a waterfall model. Don't go one after the other. Prioritize the systems. Look at the high priority systems, focus on them, and take it through those journeys. So you need to look at something like a waves. So this is what you need to achieve. So if you are coming top down, strategic manner, so you look at what all the systems you have, how many systems you have, and which are those high critical, high priority systems, where the high data sensitivity is there, business criticality is high and all that. So you plan these waves of activities. So it can be within a wave 1, there could be P1, P2, P3, P4, so many activities, so many categories of systems can be there. So doing at system level is easier. If you want to do at a asset level, it will take a lot more efforts, but here it is very easier. And with this, if you are coming top down, so you can imagine, okay, you have 100 systems. The wave 1 will have some 20 or 30 systems. Wave 2 will have some another maybe 30, 40 systems. Then wave 3 will have next. Like this is based on the priority of the assets and systems. And with this, at least you will be able to you will have a structured approach to do an estimation. What does it take? Okay, you may not get a precise dollar number, but you will get an idea about what does it take to do the migration, how much budget you need, and yearly budget you need, and by when, what systems you would have migrated, or readiness of those systems. Wave 1 will cover all our critical systems. Anyway, as per CSCRF, you are supposed to identify the business critical systems already. So you can focus on them first. You don't have to look at others. Look at them. What does it take to do the migration? How many waves are needed to do that migration? How many years it will take? And yearly budget you need. This is what you need to go on. So this is top-down strategic approach. So there is a worksheet given to you. You can start thinking about what all those high critical systems, high priority or business critical systems. You can start listing down which are those wave 1 category of the systems I would like to consider. And then you can start thinking about the volume and scale of the work involved. So I put these numbers. This is not, this is based on what I've seen estimations globally. May or may not be very relevant directly to an Indian context, but these are the kind of 50 million to 200 million numbers are being spoken about for a large organization. A telco can take $250 million to do this migration. It's not about efforts and a software change, because you may have to replace, upgrade hardware and all that. The whole migration cost can be quite huge. So if you don't go with a proper kind of an estimated approach where you can justify your plan of migration, then you will not get so much budget easily, because it's a business unusual opportunity in the sense you didn't plan it, right? It came, it's on you now. So you should start considering this. So plan, and if you have to squeeze in next 4 or 5 years, it adds even more. challenge, because the number of players in the market who can help you is also less. Unfortunately, for whatever reasons, it is still emerging. Because of the delays, like actions are not happening immediately by the organizations. So that will also add, there will be a sudden rush of activities in the coming years. If you want to meet those 2029 timelines, then rather if you can do plan, do it better. So just quickly, this is one regulatory I thought we'll touch upon this. SAB's CSCRF framework talks about the requirements. It's predominantly, there are various references here. It's not that all these things are, predominantly they talk about a few, risk assessment requirements, and do a cryptographic bill of material, those kind of things. This is a snapshot of, basically college of these things. Actual, in summary, this is what you need. So don't have to go through all that document. In summary, so the expectation is do inventory of cryptographic artifacts. So look at, do a comprehensive inventory, whether it's at rest, at transition, all those aspects. Look at various artifacts like keys, certificates, cipher suits and all that. Do a periodic risk assessment. For MIS, it is more stringent. Every 6 months you have to do. For others, at least annually, you can do this. Then based on the risk, you will do a prioritization. Have a list of high priority systems. At least one good thing is you would have already done the prioritization, business criticality based one. That will be a base for you. Add to this, if you do the quantum risk assessment with those 7 parameters, then you will be able to do better prioritization. Start looking at the crypto agility aspects of it, and whether some systems may or may not be possible to migrate. In that situation, how do you deal with it? So there are some solutions like tunnels, proxies, gateways, those kind of solutions, which will help you to get some immediate protection. Not every use case is possible for that. As the name says, they are interim solutions. You may be able to implement them. You will be able to implement and buy some time, so that you can migrate or upgrade or replace the systems and those kind of things. So those are the solutions also you may have to consider in situations where you cannot do the migration. And awareness and updating the policy requirements, of course, the skills, and if you are better equipped, better skilled, better informed, then you will be able to do a better decisions and confident decisions. Otherwise, you will, whatever the decisions you make, you may or you will be hesitant, not sure, confidence will be low. So that's what it is. And future proofing is basically keep tracking. It is changing quite heavily. NST, after 5 specifications, again there is an on-ramp process for digital signatures. It started with 40, now in the round 2 it has reached to 9. You will expect more and more such algorithms coming into the picture. And also there is a lot of discussions about PQC, QKD and all that, so where it is more relevant. But in a simple principle, global cybersecurity agencies are talking to adoption of PQC algorithms. QKD, if you want, for special use cases, you can consider. That's a simple global guidelines. So that's all about kind of basic introduction and understanding how this migration look like, how do you achieve this migration and all that. The next one is the next part of this session is about cryptography bill of material, basically inventory. So you can see simple question. If there are simple questions if you ask today, I think most of the organizations will not be able to answer with confidence. Like, do you know what all the systems which are exposed to quantum threat? You may say, yeah, everything may be, but may not be at the same risk level, right? So which are those systems which are actually using what kind of cryptography artifacts, so which are vulnerable? And what are those data systems carrying the data which have a long shelf life and data sensitivity, with a higher data sensitivity? Do you know how your vendors or suppliers are thinking about this quantum safe migration? What is their roadmap for the PQC? Do you know what does it take to do this migration? This will be most important question, because you need a lot of budget. How long it takes to do this migration? We may be thinking that confidently, we can do it in 3 years, not a problem. But is it reality? Have you done some exercise? Is it a kind of a justifiable answer? Is there any proof points? We don't have it today. So like this, like HSMs, KMS systems, all your systems, you may have to look at it and how does it take, what does it take to do this quantum safe migration? Because of these simple reasons, like, there is cryptography everywhere. We never bothered about using cryptography. We just configured something somewhere, some application would have just used. We don't even care, because that's the nature of it earlier. It was set it and forget it, and it was never in the visibility. Today it is becoming more important. And where we are using what forms and shape, there's a lot of blind spots here, especially for your legacy systems. I'm sure we don't even looked at it, what cryptography involved in that. And dependency on supply chain becomes very critical, because the dependency is huge. Vendor dependency is not all your applications are developed internally. And you may be thinking, as per the document, I'm supporting TLS 1.3. But it's quite possible in reality on the ground, you may be still supporting TLS 1.0. That's quite possible, looking at the nature of the industry and all that. So you need to understand this. So that to do all these things, there must be a structured approach to know where all, what kind of cryptography is involved in your application systems, infrastructure and all that. But thing is, there is no one or two cryptography artifacts. There is a huge list. This again, I'll say this is not a complete list. Okay, I try to list down as much as possible, non-exhaustive list. So there is algorithms, keys, certificates, protocols, cipher suits, libraries, stores, configurations you do, PK systems, KMS systems, HSM systems, database encryption, tokens. This is a huge list. It goes on. I'm sure you'll be able to think few more. If you start thinking about it. So that's a challenge. And how do you approach this problem when such a such complexity is involved? And it shouldn't become overwhelming, and you need to have a better structured approach to this problem. Then you will be able to deal with this little more comfortably. Otherwise, you get overwhelming and you will just delay the action. So rather, yes, we need to look at all these cryptography artifacts. In each of them, at the end of the day, these are the cryptography artifacts. Within that, what kind of algorithms are there? Is it vulnerable, not vulnerable? Basically, is it a public key encryption or asymmetric key encryption, hashing, or any of them? How are you using this? In what forms and shapes it is used? It may be it may be sitting in files. It may be sitting in in your code. In the various forms, all these things will be sitting, right? So you need to identify them. So not a problem. This is being solved in some various forms and shapes. A lot of vendors are also offering various tools and solutions to this. But you need to know that there are so many aspects you need to look at it. It's not just one problem. I know there is no one keys and certificates. Everyone talks about these two only, but there are a lot more things you need to worry about. Most of the discussions when I initiate, I think everyone thinks about mostly certificates and keys. That's all. But there is larger picture you need to worry about, and it can live in various forms and shapes and various places. Your applications, the whole source code, you might be hard-coded, you might have used libraries, various libraries are possible. You might have your own internal libraries or open source libraries like OpenSSL, those kind of things you might have used, and some configurations where you have simply configured without knowing what does it mean or impact, or you are just kind of legacy applications you're just carrying forward because it has to backward compatibility or in interoperability reasons, you just maintain those configurations. You need to understand those. On the network and a lot of protocols, there are most predominantly TLS series of protocols, your IPsec series of protocols for your VPN firewall use cases, and all these things. Everywhere you are using cryptography there, and though you need to understand from the network and communication perspective, and all your infrastructure, though you will have hardly any control on them, right? So you buy a VPN or a firewall, either you have to replace or upgrade. You don't have any utmost you can do the configurations, so you cannot change the code. So you need to understand those devices, firewalls, load balancers, routers, TPMs, HSMs. You need to start understanding whether they support PQC today or not. If they support, how can you reconfigure them to do the support PQC? If not, what is the plan to do the upgradation? Is your vendor having the migration plan or not? So this is a big challenge. Infrastructure looks like, mostly we think about our applications, but your infrastructure matter. And there is a problem like your application, your server and client may be working, but your intermediate boxes are not supporting. Your ossification comes into action. Both can talk to each other, but intermediate things are not enabling you to talk. So there's some kind of those challenges will also come. So that's where the sandbox environment testing, looking at each box will help you. And if you are dependent on cloud and all that, each of the cloud providers have migration plan. Some of them are already started supporting PQC use cases for some of the services like KMS services but some are not. But don't think that the cloud vendor will take care of it. Cloud vendor will take care of their infrastructure, but they also give you services. You have taken the KMS, you have configured, you have created some keys. Those keys are created by you. You are responsible for your applications. So the shared responsibility model will come to the picture. Then all that migration you have to take it. That's your responsibility. Cloud is enabling. Though all the platforms are not supporting all the use cases, all the services, but they are already working. They have clearly defined their migration plan and all that. So you should start closely looking at them. Look at all those cloud use cases, applications, and how are you using them. Start doing planning and migration. Some cases wherever possible, if there's a high critical system, do it. So those kind of things you need to take care. The challenge will be predominantly for your certificates, especially the web PKI side of the certificates, can be challenging. If it is private CA, it may be easy. You can simply create those certificates internally and do it. But web PKI is basically you depend on the external ecosystem. Whole ecosystem has not moved, but you should be aware of that. And again, the databases, your whole CI/CD pipeline, you will see the cryptography exists, lives in all these places. And on top of it, there is OT, IT, OT, product and cloud security. Each domain, security domain will have a different approach. There are some nuances you need to consider when you do this migration. So yes, so those are the cryptography artifacts where all it exists. So can I buy one tool and do this? Unfortunately, no. There is no single vendor in the world who offers all the capabilities on a single platform. Like you have to do source code scanning. It's obvious. Okay, you will think that I need to do source code scanning and try to collect what kind of libraries are where the cryptography is used. And you may have to do dynamic. Some libraries are getting loaded dynamically, and you may have to do that scanning. File system and endpoint scanning. At the end of the day, you have to go and look at every file and see what kind of file it is. Does it have a key? Does it have a certificate? Some files will have both. All that will. There are various formats that exist. Active network scanning. Basically, some cases where you may not be able to go and deploy things. Maybe you have to just probe and collect the information about that. Then the passive network scan. In some cases, you will not be able to go and penetrate. Rather, you just collect the packets and actively used algorithms, actively used cryptography. You need to look at it. Then, if you don't have, you may have to do the binary scanning, firmware scanning, right? Then managed systems. This may be the easier and most comprehensive and reliable one, where you have KMS systems, HSM systems. You call those vendor APIs and collect the information. This is one good place to start as well. And you may have, again, the databases, you'll have different approach. You may have to look at the configurations and all that. And on top of it, when you ask your vendors, give me the CBOM, they might give in different formats. Maybe they might give in following the CBOM structure, but they are all individual JSON files and Excel files, CSV files they will give. They will be lying all around. You have to put all of them together so that you have a comprehensive view for each system. And again, the last but not the least, the passive discovery will be quite good place to get started. So you may not want to start, especially regulated entities. This is what I see. So deploying the tools, deploying agents, deploying scanners can become challenged. So at that point, at least get started with some kind of inference-based, evidence-based, looking at the configurations, looking at anything supporting. Maybe you can start with a simple questionnaire, but definitely it is not the end goal. Don't think that will solve your problem. It is help you to get started, but at least it will get started. So look at simple questionnaires, and within that ask for evidences, look for configurations of files, look at them and see whether it's what the system owner claims and what actual configuration is reality. Again, as I said, there may be intent and reality gaps will be there, but at least you will get started. So more the evidence you collect, then your confidence level is higher. You can go with this at least to get started, and as you go, you may be able to achieve maybe 30-40% of it. It's not complete. Good story. Based on the use case, based on the application category and system, you may have to pick and choose the right scanning methodology. So start thinking about what are those high priority systems. Within that, what are those asset categories that exist? For those asset categories, what are the cryptography artifacts that are involved? And within that, what kind of algorithms you expect? If you go with that approach, then you are kind of a bounded, well-defined approach, and your scoping will also be very easy to manage. So in a cryptography bill of material or any kind of a thing, what you will have is a lot of details about algorithms and protocols, the keys, key sizes, what kind of certificates are there, the PK system understanding, what libraries are involved in the protocols, what cipher suits are used, and what kind of configurations that exist, and also you may want to add the data aspects of it so that, sorry. So you will be able to understand. So these are the kind of information you expect in the cryptography bill of material or the inventory. Look at the asset. Look at the asset, cryptography artifacts involved in that. Within this cryptography artifacts, what kind of algorithms are there, and start classifying them vulnerable or not vulnerable. And if there is any, if we can add additional metadata around that, it will also significantly help in your risk assessment as well. So there is a standard. This is not like there is one standard called Cyclone DX. It's very similar to your CBOM. SBOM. You are more used to that. This is from Cyclone DX. There is a document you can go through. Each of these cryptography artifacts has certain properties. You will collect that information. You represent in a standardized machine readable form. That's what this Cyclone DX standard as a CBOM specifies. At this point of time, there is a kind of discussion, I will put it that way. Not everyone is trying to adopt, but there are some legacy players, they say it is not a complete solution, but some players are saying it is good. So if you can get both, like a pretty simple inventory, tabular form along with that CBOM with a JSON file. Maybe it's a good idea to have both. You don't have to worry what is good, what is not good, because that's a debate is still going on, because it got introduced just a couple of years back. So it will help you to address these various use cases. It will help you to do from a cryptography asset management. You can look at these as a separate asset classes, and you can identify vulnerable. You will start seeing that it's not about quantum threat. Even the legacy, you may be still using TLS 1.0 or RSA 1024, those kind of stuff there. So you can start identifying. It will help you to improve your security posture as well, and definitely the intent started with a PQC readiness perspective. And many regulatories talks about preparing this CBOM and have this ready. But as I say, CBOM is not the end goal. Please note this. If you do the CBOM today, next 1 month, it will not be same. It will be changing. So don't think I'll do one-off activity, one time I do it and forget it. So if it is a regulatory requirement, you do this periodically and submit it. But if it is for your own security and quantum safe migration perspective, have prioritized approach. As I said earlier, go sequentially and keep enhancing your quantum readiness. Just to give kind of a perspective, which this is what I think you should take away, important one. So what are the asset categories you will have? And in each asset category, what are the various types of cryptography artifacts? If you take a simple web server, right, you will have a protocol, security protocol, TLS. So what kind of protocols that has 1.0, 1.1, 1.2, 1.3, what all it supports. And cipher suits, what kind of cipher suits are configured within that, and what all is supported. You might be thinking when you do the connection, based on the handshake, it might be picking up the right one. But you might have configured for all kind of, for various reasons, maybe legacy reasons or interoperability reasons. You might have done the configuration for various protocols. So that's where your understanding the cipher suits configured will matter. Then you'll also look at the public key associated with that. Most importantly, the certificate chain. So in the whole certificate chain, you need to see what is your leaf certificate, intermediate, and root. The whole chain. How does it? What are the algorithms it is used, signed? Mostly today, at least, you will not see. Only the key exchange use case you will see better. Possibilities are there. If you have used Cloudflare, CDN and all those support, then you are already would be supporting X2459 plus MLChem 768. You can go, sometimes your website is already supporting if you are using any of these services. So this is important. Look at the asset category, identify the cryptography artifacts involved in that asset category, and within that what kind of algorithms are there, what kind of sizes, configurations are there, is it vulnerable to what kind of threat, and then you will be able to create. So instead of looking at individual algorithm, individual artifact, if you look at from an asset, the advantage is you will put together a group of assets, creates a system. So at a leadership level, you think about a system level or a use case level. So for a particular use case, there are a group of systems that come together. Within each system, there are a group of assets, various asset categories. Now, if you build, you will be able to build the hierarchy very easily. So when you are reporting to your management or leadership or a board, you can simply say, my trading system is quantum ready, or so much % is done, because you are built like this. If you just look at only cryptography artifacts, my certificate is upgraded. So what does it mean? It doesn't mean anything to you. But when you say this particular system is quantum ready, I have done the quantum readiness assessment for this. Or if you look at, if you are also looking at only the assets, that is also doesn't mean anything to you. One web server is ported, so what? I don't know, what does it mean to leadership? So technically that's what you will do at the end of the day. But at least when you are preparing the strategy and the hierarchy matters. So look at those systems, within that what all the assets, within each asset, what are the asset categories? The pattern is, there is a clear pattern. This particular asset, most probably category will have, these are the possible cryptography artifacts, these are the possible cryptography algorithms. You can expect. So there is a easy to correlate and start approaching this problem. And for each asset category, you can decide what is the right cryptography discovery methodology you can adopt. What is the right tool? So things will fall in place easily. So start thinking about in this manner. It's easy to deal with this problem, even though it looks comprehensive and quite intimidating. So a simple mental model for you to take away. I think understand the threat, do a cryptography discovery and inventory, do an assessment, plan for the migration, and do this execution. Most importantly, don't go with waterfall model. Don't say I'll do complete cryptography discovery. Doesn't make sense. The simple reason is, if you have 100 systems, only 20-30% of those systems are business critical, and which you are already prioritized. So focus on them.
do a cryptography discovery, go through this journey for them. And within that, there may be P1, P2, P3s, priority 1, priority 2, priority 3 kind of things may be there. Focus on them. It matters, like your resources are limited, people are limited, money is limited, time is limited. Rather, focus on what matters. Go these cycles, one after the other, waves, like the way earlier we showed. Waves, you will have multiple waves across multiple years, but wave 1 will be focusing on those critical systems, maybe P1 or P0, I mean, very high critical. Like this, you will go. So iteratively, you do this. Don't go, though the regulatory bodies ask you to do the complete cryptographic bill of material. For a practical migration perspective, it may not be the best approach from a migration and resource allocation perspective, but for regulatory reasons, you may have to do it one time. Anyway, good thing is they ask only once in 6 months or once in a year, so that's one way it is good. But for your actual execution of the migration, go iteratively, focus on most critical ones. It may be shorter waves also. You may want to focus on just 3 systems or 5 systems. It's better, you will be able to deal with them better, and that helps you to learn the process a lot better. You know, you will incorporate the learnings sooner. If you just go, you're doing only one type of activity, then you go do, it's not going to help you much. So this is what you please take away. This is the kind, I think you should start looking at it. And there is also in the handouts, how do you approach this business plan? You know, how do you prepare such proposal is given there. Start thinking about it, how to do this. And also identify how do you approach, what are those high business critical systems and assets, and what is a possible cryptography discovery methodology you will adopt. A simple handout in that you can start writing. Just the process of thinking few things will help you to open up a lot of questions for you. Then you will be able to start finding the answers. Otherwise, once you, till then, I think it is not, kind of, there is a gap between what we know and what we can put into action. So maybe you can look at simple where you stand, because a simple self-assessment you can do where you stand. Awareness, like we do, are completely unaware. I don't think so. At least most of us may be falling in 1 and 2 categories here. We are aware, but we are not taken a lot of actions. That's where I think start doing immediate actions. Come up with a 90 days plan. What is that first few things you want to do? It's a simple template is given. You can start filling that so that you will start thinking in those lines, and what is the regulatory expectations, what is your organizational expectation, put those two together and start putting those actions into that sheet. It can become a comprehensive sheet, so but at least get this started. And once you are done, then you will start moving to the next level. So we do a cryptography discovery for the high priority system, do a risk assessment. Risk assessment is, again, you can do a simple, okay, is it vulnerable, not vulnerable, to the business side of the risk. You can say timeline, or timeline aspects of it, timeline risk analysis you can do, feasibility risk analysis you can do. You can do data risk analysis, you can do the vendor risk analysis, you can do quantum threat risk analysis, you can do basic cryptography itself, and the policy compliance requirements if there are any. All these aspects you may want to consider, depending on, you may pick up 1 or 2 or all of them, make a decision. At least it will help you to do the risk assessment in a comprehensive manner. Crypto agility, again, start looking at it. Can I do it actually the crypto agility or not? So those kind of things, you'll start taking those actions in the just initial 1 to 3. Afterwards, migration will take a long period, even though it will be the long pole for you. But this preparation will help you to deal with this lot better, because if you take some decisions, then you may have to do refactoring and reworking. That's not a very good idea. Like, you're just putting the investments for the same activity. Yeah, so I think that's time we have.